In this video, we're going to extend what we've been building so far, and we're going to add some new features to this project with Django and HTMX. So if we go to models.py, we have this transaction model here. That's the central model of our application. And in this video, we're going to take the amount for each transaction, as well as the type of transaction, and we're going to calculate totals based on this data. So for example, you might have a bunch of transactions that have a type of an income or an expense. You might want to total that up in the database. We're going to use Django's ORM aggregation tools in order to do that. And the way that we're going to do that in this video is by adding some custom QuerySet methods and then creating a custom model manager on the transaction model. And we're also going to write tests for that logic using pytest and the 𝗵𝗽𝗶𝗹 package for generating fake data. Finally, after we've done that, we're going to display the results on the UI, and that's all going to be integrated with HTMX. So let's get started. What we're going to do to start with is we're going to create the methods to calculate the totals for each type of transaction. So across the whole database for the given user, we want to see how much have they earned in income, and that might be between two dates. We're going to see that later in the series, and also how much expenditure has that user spent. And again, that can be filtered between two dates. Now what I'm going to do to start with in this video is I'm going to create a file called managers.py. Now before we do that, actually on the left hand side, here's the structure of the project that we have, and each video has its own directory. Now you can get the code for these videos on GitHub. There's a link to this repository below the video. We're going to copy video 2, which should be in the repository, and we're going to copy that to a new folder that I'm going to call video 3. And then I'm going to take video 3, which is a copy of the previous video's code, and that's going to be the starter code for this project. So I now have video 3 open in the directory, and we have the Python virtual environment activated. What we're going to do is go to the tracker Django application, and I'm going to create a new file in here. And as I said, that's going to be called managers.py. And if you're creating custom Django model managers or query sets, you can put them in a file called managers.py, or if you prefer, querysets.py. And what we're going to do here is we're going to create a custom query set, and that's going to have 4 custom methods that we're going to add to that query set. So let's start by importing Django's models. From django.db, we'll import the models. And what I'm going to do here is define a class that I'm going to call transaction query set. So that's quite a long name, but it's going to be called transaction query set. And that's going to inherit from something in Django, and that's the models.querySet class. Now, when you override these query sets, you can define methods in the class. So I'm going to define a method now called getExpenses. And that's going to take self as an argument because it's a method in the class. And then what we're going to return here is the normal query set, but we're going to add the filter statement. And we're going to filter by the type of this particular transaction. Let's go back to models.py, and you can see that the type of the transaction is a car field, but it's linked to some choices. And it's these choices here on lines 19 to 22. So a transaction type can be an income or it can be an expense. So for this method, getExpenses, we are going to filter down all of the transactions to only those that have a type of expense. So that's a very simple method that we're using on the query set, but it's going to allow you to define a nice API around this data. And we're also going to copy this, and I'm going to paste it below, and we're going to define another method. And I'm going to rename this to getIncome. And that's a very simple change. We're going to change the filter to filter down to the transactions that have a type of income. Now these are the base 2 methods that I'm going to use, and we're going to build up on these with a couple of extra methods now. What we're going to do is define a method called getTotalExpenses. And again, that will take self as a parameter. Now what we want to do here is we want to filter to the expenses, and then we want to aggregate that data and return a total, which should be a number. So let's start by filtering the query set by calling getExpenses. So it's self.getExpenses, and that's going to filter down based on this line of code above. And then that's going to return to us another query set. We can chain additional methods to that. And we're going to chain the .aggregate method to this. And we're going to aggregate, and that's going to use a models.sum, and we're going to get back the total for the expenses. Now I'm going to move this to a new line here, just so that we can see it better. So what we're doing is we're aggregating, and we want to get back a total. So we're giving the field that we're going to get back the name of total, and we're calling models.sum. Now when we want to sum over a particular column in a table, in Django we just refer to the name of the field, and the field name is the amount. You can find that in models.py, and that's a decimal field. So we're going to sum the amount, and that's going to give us back a dictionary in Python after we aggregate that, and we need to index into that dictionary and get the total. So let's grab that key of total, and if we don't have any objects, we want to get back a default value of 0. So just to cover what's going on here, we have a method called getTotalExpenses. And the logic for that is to filter down the transactions to only the expenses and then take all of the rows for those expenses and aggregate to get the total over the amount column. Now we're going to copy this method and I'm going to define a very similar method below here. And again, that's going to be called getTotalIncome. And the method it's going to call is the getIncome method that we defined on the query set. And then we're aggregating again over the amount column, and the rest of this logic can remain the same. So why are we doing this? What we're going to do is save managers.py, and we're going to go back to models.py, and I'm going to scroll to the top here, and from managers, we're going to import that new query set that we defined. So that was the transaction query set. Let's import that and copy the name of that. And then we're going to go down to the transaction model, and just below the fields that we've got defined here, I'm going to create a value called objects, and that's the default name for the Django model manager. And what we're going to do here is we're going to paste transaction query set, and the query set subclasses in Django, they have a method called asManager. If we call that method, that's going to create an instance of a model manager in Django, and it's going to have all of the custom methods that we defined on this query set available on that manager. Now, if you want to know more about this, there's a page in the Django documentation on managers. I'll leave a link to that below the video, and there's a section on the right hand side. It's this one here, calling custom query set methods from the manager. So if you define a query set, and that inherits from models.queryset as we're doing here, what you can actually do is you can define a manager that returns that query set within its getQuerySet method. But the shorthand for that, if you scroll down to this section, is you can call the asManager method and then add that to the model, and that gives you access to the model manager with all of the normal methods, but also with the custom methods on the query set that you define. So there's a couple of different ways of doing this. Let's now go back to VS Code, and I'm going to save models.py. We now have a custom manager on the class, and we're going to test that custom manager out by expanding the shell here. And we're going to run python manage.py, and it's the shell plus command from Django extensions, and that's going to load up the Django shell with some imports. Now at the bottom of the shell, let's refer to the transaction model here. You can see that that's been imported and it's available to us. And what we normally call on these models is methods on the manager. So the manager is the .objects property on the model. And normally we can call methods such as transaction.objects.all, and that's going to return all of the rows in the database. But what I'm going to show you now is that you can actually refer to these custom query set methods that we defined. So if we go back to managers.py, we defined a method here called getExpenses. And for some reason, the terminal that I'm working on seems to have been killed here, but this is the method that I was going to define, or was going to call. It's called getExpenses. So let's load the terminal again. So it's python manage.py shell plus, and then we're going to get a reference to the transaction model. And that has the manager objects, and we're going to call get_expenses. Now that's not normally defined on a Django model manager, it's a custom method. But when we call that, you can see we get back transactions, and these are all expenses because of this filter statement that we've defined in that method. What we can also do is we can get the total expenses. So I'm going to tab up to get back to that query, and I'm going to replace the method that we're calling with getTotalExpenses. And actually that's not returning anything because I've forgotten the return statement. Apologies for that. Let's go back to the method, and we need to return the value here from the aggregate function. So let's return that. And again, we'll go back to the terminal here. And if we go to shell plus, we can call transaction.objects. And then the method was getTotalExpenses. And the number we get back is a decimal instance, and it has this value here. So this is the total transaction amount for expenses that are in this database table. Let's now move on and note that you could do the same for getTotalIncome. And in fact, let's quickly do that on the shell here at the bottom. If we call the getTotalIncome method, so I'm going to change the name of the method here, you can see we also get back a decimal instance. So we can use these in our application to actually get the totals back and aggregate the data that the user has added to this application. Later on, we're going to show this on the page, but before we do that, it's important to write tests when you're dealing with this kind of logic, when you're aggregating over data and you want to make sure what you're returning is accurate. So what we're going to do in this video is install a couple of packages. First of all, we're going to install pytest, and we're also going to install a plugin called pytest Django. And that provides a lot of utilities for writing tests when you're working with Django. And finally, we'll install a package called 𝗏𝗏𝗽𝗁, and this allows you to easily generate test data for your tests. Now I've left a link to each of those packages below the video. Let's go to the terminal and we're going to paste in this pip install command. So we're installing pytest, we're installing pytest Django and 𝗏𝗏𝗽𝗁. Let's execute that command. And what I'm going to do while that's executing is go to the pytest documentation. So pytest makes it easy to write small and readable tests, and it can scale to support complex functional testing for applications and libraries. What I'm going to do in this video is start by creating the pytest configuration file. So let's go back to VS Code and we're going to go to the root of the project next to manage.py, and we're going to create a file here called pytest.ini. And we're going to add some settings here for pytest. So let's define a block for pytest. I'm going to add a couple of options here. So let's set this to -rp, and that's going to allow us to see the output of these tests and print statements on the terminal. We're also going to add a reference to the Django settings module, and that's going to tell pytest how to load in the Django settings. Now at the moment, in our project directory, we have a settings.py file. The project directory here is called finance project, and then it's a settings file, so we can reference that with this syntax. And of course, if you have a dedicated settings file for your tests, you can reference that here in the Django settings module. And the final thing I want to add is a Python files variable, and we're going to set that to tests.py and also test_wildcard.py, and finally wildcard_tests.py. So basically any file that has the word test in it, we want pytest to find that within this project and find the tests within that file and run those tests. Now that we've done that, we're going to go back to the tracker directory, and I'm going to create a new file in here called factories.py. And this is where we're going to import a module called factory, and that's basically a module called 𝗏𝗏𝗽𝗁 that's going to allow us to generate fake data. What I'm going to do is go to the documentation for 𝗏𝗏𝗽𝗁, and I'll make this text a bit bigger here. This gives you the ability to replace fixtures in Django. Now fixtures are JSON files, and these are static and they're hard to maintain as your project changes, whereas 𝗏𝗏𝗽𝗁 defines a class-based approach, so you can build up complex objects and relationships using 𝗏𝗏𝗽𝗁. And as your project evolves, I think it's easier to use this and change this along with the models in your application. So I think this is a slightly better approach than using JSON fixtures in Django for your tests. What we're going to do is go to the section on using 𝗏𝗏𝗽𝗁 with ORMs. And with Django, what we can do is inherit from a Django model factory class. And I'm going to copy the code here for this user factory, and we're going to define that in VS Code. So let's go back to VS Code and paste this in. So we have a user factory class that's inheriting from Django model factory. Within that we have a meta class, and we need to link this to the user, and the user in this application is in the tracker.user project. So the tracker application and the user model, and then we're getting or creating based on the username. We can leave that as is, and you can define some defaults for your model here, and you can see the default username is John. When you actually create a user factory, you can override these defaults if you need to. We'll see examples of that later in the video. What I'm going to do now is import the models that we have in this application. So from tracker.models, we're importing the user model as well as the transaction and category model. And we can actually set this directly to the user model now. And what I'm going to do is replace the username property here with some properties that I've written. So factory comes built in with the faker module in Python. And faker allows you to generate some fake data simply by calling some functions. For example, here, we're passing the first name generator to the faker object, and that's going to generate an example or a dummy first name, and we can do the same with the last name field on the user. For the username, we can define a factory.sequence, and the sequence that we're defining here takes a number n, and it's going to create a user based on that number. What I'm going to do now is create a couple of extra factories. Now, if you're not interested in the factory stuff, you can skip to the next section of the video. What we're going to create now is a category factory. And again, it's going to inherit from this Django model factory class. So let's paste that in there. And the meta class should link this factory to the category model. And again, Django_get or create. I'm just going to copy that from above, and we can paste that in here. We're going to set that to the category's name field. So factory boy is going to try and get a category with the given name it generates. And if we look at the category model, you can see that it has a unique constraint defined. So we should only have one category per name. The database is not going to allow duplicates, so we can set the get or create field to the name field on the model. Now, when 𝗏𝗏𝗏𝗏 generates a fake category name here, what we want to do is we want to define a field, and I'm going to make this on a new line so we can see it clearly. So the name field we want to set to a 𝗏𝗏𝗏𝗏𝗏iterator. And we're setting the values of that iterator, the sequence that we want to use, to this hard-coded list here that contains some default categories such as bills, housing, and salary, and so on. So that's our category factory. I'm going to scroll down and we're going to define another class now. And that's going to be called transaction factory. And again, it's going to inherit from this class here. So I'm going to copy this and we can paste that in here. We need to define that meta class. So let's define that and link this to the transaction model. And then we're going to define the fields here for the transaction. Now the user that's attached to the transaction, if we look at models.py and scroll down here, that's a foreign key field. That means that the transaction has a foreign key reference to a parent user model. So in order to replicate that in 𝗏𝗏𝗏𝗏𝗏, you can create what's called a subfactory. We can call factory.subfactory and pass in the user factory that we created above. And what that means is that when we create a transaction using 𝗏𝗏𝗏𝗏𝗏, it's automatically going to create the user that's attached to the transaction by looking at this factory here and returning an instance based on that. So that's the user, and we can do something very similar for the category foreign key on the transaction model. It's going to be a factory.subfactory, and this time we're going to link that to the category factory. So what else do we have on a transaction model? We have an amount, and I'm going to set a default here of just the number 5. We have a date, and I'm going to set this again to a factory.faker call. And let me scroll down here and we'll define the parameters for this on a new line. So I'm going to use a generator in Faker called dateBetween, and as the name implies, that takes a start date and also takes an end date here, and it's going to generate a date in between the two. So for the start date, let's create a datetime object, and before we fill that in, we're going to scroll to the top, and from the Python datetime package, we need to import datetime. So from datetime, let's import the datetime object, and we're going to scroll back down here. I'm going to set this to a value. So I'm going to set the year to 2022, and let's set the month and the day to New Year. So the 1st of January 2022, and let's set the end date to datetime.now, and we need to convert that from a datetime instance to a date. So we're going to call the .date function. And we also need to convert the start date to a date object. So let's call .date on that as well. And one final field here, I'm going to paste it in. So I've pasted this field called type onto the transaction factory. And again, we're going to reference Faker here, and it's the random element generator. What we pass to that is a sequence. And the sequence that we're passing is a list comprehension that looks at the transaction type choices. So basically that's going to be income and expense. And it's going to extract one of those and return a random element for each one. So I hope that makes sense. I'm now going to save factories.py. And we now have a factory for each of the models in this application that allows us to very quickly generate fake data for those models. So let's test that out again in the Django shell. I'm going to run python manage.py, and again it's the shell plus command, and that's going to load up the shell. And then what we're going to do is import the factories. So at the bottom here, from tracker.factories, let's import every one of those factories that we defined. And then I'm going to instantiate a transaction factory here. And when we do that, we get back a transaction. So what we can do in 𝗏𝗏𝗏𝗏𝗏 is not only generate a single transaction, but we can actually generate a batch of these as well. So I can call create_batch, and I'm going to create a batch of 10 transactions. When we execute that, we get back 10 transaction objects that are saved to the database. And they're saved to the database because we inherit from the Django model factory class. That will automatically save them unless you tell it otherwise. And I want to show one last thing we can do with the transaction factory. So I'm going to create a variable called transaction, and we're going to instantiate the transaction factory, and we're going to pass through a default value for one of the fields. So for example, on the transaction factory, we're setting by default the amount to a value of 5. But when we instantiate the factory, we can override this by providing an argument. And let's say we wanted to set this to 1155. We can do that here, and that's going to give us back a transaction object. When we look at that object, we can look at the amount on that, and we can see that we get back the value that we passed in. So that allows us to override what's defined by default on the class if you need to do that. And frequently in your tests, you might want to do that, especially when you have relations between one object and another. So this is all working now. We can exit out of the shell, and we're going to start writing some tests. So what I'm going to do is go to the tracker application here, and I'm actually going to create a new folder that I'm going to call tests. And if we scroll down to the application tests.py file, we can actually remove this. Once that's gone, we can go to the tests directory, and I'm going to create a new file here, and it's going to be called conftest.py. What we're going to do in this file is we're going to write what's called a fixture in pytest. And if you're not sure what that is, we did a video on pytest recently, and that contains some explanation on fixtures. It should be appearing on the screen now. In this file, we're going to import pytest, and we're going to import the transaction factory that we defined in factories.py. Now what we want to do is write a fixture that allows us to inject a batch of transactions into a pytest function. So I'm going to decorate this with pytest.fixture, and then we can write a Python function under that decorator called transactions. Now this particular function, what it's going to do is return a batch of these transactions. So we're going to take the transaction factory that we created, and we're going to call a method called createBatch on that, and that allows you to pass a number into that method. And that's the number of the instances that you want to create for the given model, in this case for the transaction model. We're going to create 20 here, so let's pass the number 20 and save conftest.py. Now any fixture that you define in a conftest.py file is going to be available by default without even needing to import it in the test.py files. So within the tests directory, we're going to create another file, and it's going to be called test_models.py. And we can now write some pytest functions in this file. So let's import pytest, and we're also going to import the transaction model. And I'm going to define a test here called test QuerySet getIncome method. So on the QuerySet, we wrote a method called getIncome. If we go to managers.py, remember that was the method that is filtering down the transactions to only those that have a type of income. And we now want to write a test for this method. So let's go back to our test file. So this is going to test the getIncome method that we defined on the QuerySet. What we need to do though is inject the transactions that have been created by that factory. So we're injecting something called transactions here, and that matches the name of the pytest fixture. So this transactions fixture here is going to create 20 transactions using the factory, and then by injecting it in as a parameter here, we're going to have access to those transactions within this pytest function. Now we need to add a decorator to this function here, and that's because by default pytest is not going to let us access the Django database. So what we can add here is a pytest mark. So it's pytest.mark, and there's a mark called Django_DB. Now remember, we installed the pytest Django plugin. This is provided by that plugin, and if you decorate a function with this, it means that your pytest function can access the test database. So if you're doing any kind of logic that means that some data is going to get written to the database or read from the database, you need to add this pytest mark to your function. And that's the case here because these transactions that are created and stored in the database, because they're being stored in the database, we need to actually use this mark here to tell pytest that that is okay. Now what we're going to do is we're going to get a query set here by calling transaction.objects, and then it's going to be the .getIncome method that we defined. That's the custom method on the query set, and that's going to filter the transactions and only return the incomes. Now once we get back that query set, we're going to check that it contains more than 0 records. So let's check if QuerySet.count is greater than 0. Remember, we're getting transactions here, and then what we're doing in the database is we're getting them by only the transactions that have an income type. But remember, on the factory, if we look at factories.py, the type is randomly generated from the choices. So when we create these 20 transactions, we might actually get back 20 that all have expense type, and therefore the getIncome method might return an empty query set. Now actually that might not be an ideal method for a test, so what I'm going to do is actually change this up. Rather than using random element, what I'm going to do is change this up, and just like we did above here when we created an iterator for the name, we're going to also do that for the type field as well. So let's scroll down here and use factory.iterator, and I'm going to remove this random element stuff, and we're just going to pass in a Python list here containing the transaction type choices. And that means that the first one that's going to be generated is going to be an income, the next one is going to be an expense, and it's going to cycle through that process and create one income and one expense and so on. And that means if we go back to the test, the getIncome method is guaranteed to return some transactions with the type of income. So now we can remove this, and I'm going to create an assertion here. So the QuerySet.count should be greater than 0. And the important test for the getIncome method is we want to assert that all of the following are true. So we're going to create a list comprehension, and we're going to say transaction.type is equal to income, and that's for each transaction in the query set. So the query set we're pulling out here gets all of the income values using the custom query set method that we want to test. And then what we're doing here is we're asserting that every single transaction that we get back in that query set has a type equal to income. So that's the expected behavior of the getIncome method. And what we can also do is copy this method, and I'm going to create another one just below, and I'm going to change the references to income to getExpenses. So on the model manager, we're going to call getExpenses, and we're going to assert the same thing, except here we're going to change what's expected to expense, and that matches the second element here in that tuple of choices. So let's now test this out. What I'm going to do is expand the terminal here, and I'm going to clear it out, and what I'm going to do is run pytest. So let's see what happens when we run the pytest command. And we get some output here, and you can see that it's collected 2 tests, which makes sense because we wrote 2 test functions, and these 2 tests seem to have passed. We can see in green at the bottom, 2 tests have passed in 1.11 seconds. So that's good. We now have working tests for the query set methods that we defined. We're now also going to add tests for the total methods. So we have 2 methods in the query set, getTotalExpenses and also getTotalIncome. Let's go back to the pytest file here, and we're going to write 2 more tests. So I'm going to scroll down, and we're going to define a function called testQuerySet getTotalIncome method. And what that's going to take again is the transactions. So we're going to create those 20 transactions from the pytest fixture. We also need to access the database for this. So let's copy pytest.mark.django.db and decorate this test. And what we're going to do is get back a value for total income. We're going to call transaction.objects.getTotalIncome. And that's the custom method that should return the total over all income transactions. And then let's create an assertion here. We're going to assert that total income is equal to a value. And I'm going to use the sum function, that's the built-in in Python. And we're going to look at t.amount here for each t in the transactions that have been passed into the method from the fixture. But we're only going to consider the transactions whose type is equal to income. So I'm going to get rid of the sidebar here so we can see this as a full line of code. What we're doing is we are injecting transactions. There should be 20 of those. And then we're calling getTotalIncome here. That should hopefully return a number for the total income over those transactions. And then we're checking if that is equal to this statement here. Now this statement uses the sum function, and it uses a generator within that. We're looking at each transaction in the generated transactions from the pytest fixture, but only those that have a type of income. And we're summing up the amount for the query set that's returned from this statement here. Now we can do something very similar if we copy this function again, and I'm going to paste that just below here, and I'm going to change the references from income to expenses. So we have a variable called total income. Let's change that to total expenses and call the getTotalExpenses function. And then finally we're going to take the total expenses that are returned by our custom method, and we're going to check that that's equal to this value here. We need to change the type though to expense at the end of this statement. So now we have 2 extra pytest functions that are going to test the other 2 methods that we had in our custom query set. Let's again run pytest on the command line, and we're going to see that it's collected 4 items, and all of our tests have passed, as you can see at the bottom. Now there are some ways that we can probably improve this process. What we can do is go back to factories.py, and rather than hard coding an amount here of 5, we could set that to a random number, for example, so that each transaction has a different value for the amount. Or we could inject a different value using our fixture. So let's bring back the sidebar, and we can go to conftest.py. One way to do this here, if we import the random module, is to pass an amount that has a random value. So for example, random.randint between value 0 and 100. We could pass that in randomly for each one of the batch that we create here. But we're not going to do that here. Let's just leave it the way it was. Our tests are passing, and we have some basic tests around this query set functionality that's been written in pytest, and that uses these factory boy classes in order to generate test data. Now the next stage in this application, if we go back to managers.py, is to get the values back from these methods and display them in the user interface. So what I'm going to do is just start the Django development server, and we're going to show the user interface at the moment. And when we go back to the application, we have this UI at the moment. We have a transactions list that contains a table of all of our transactions. What we want to show above that is the total values. So for example, we want to sum up all of the income that's been generated. We want to sum up all of the expenses. And then we also want to take the difference between the two, and that's going to give us our net income. So we want to show that information just above the table. And later we're going to add some date filters to the right hand side with HTMX. And that's going to allow us to filter our transactions between two dates. And we want those totals that are going to be above this table to update dynamically when we filter between those dates. That's all coming later in this series. In the next video, we'll implement the user interface to show these totals, and that's going to be hooked up with HTMX again. In this video, what we've done is we've created a custom QuerySet object with these custom methods, and then we registered that on our model. So if we go to models.py, we created an objects property and set that to this statement here. And then we wrote some tests around this functionality. So we created a pytest fixture that will inject some transactions, and that's using a factory that we created. And then after we've done that, we can use the transactions. If we go to our test functions here, we're injecting that in, and then we can define the logic and use pytest to test the actual methods that we've created on that query set. So that's all for this video. If you've enjoyed the video, give it a thumbs up and subscribe to the channel for more. And consider buying the channel a coffee if you're finding this content useful. It'll encourage me to make more videos. And thanks again. We'll see you in the next video.